we have learned so far is all for sketching quadratics. Okay, it's all sketching quadratics. And now this one is a separate content, but which is a very, very important content. This will relate to quadratic formula. That's a good time to talk about that as well, because we just learned quadratic formulas yesterday. Okay, this exercise will closely relate with the quadratic formula. So this is called the intersection of lines and parabolas. So when we're trying to solve simultaneous equation for a linear and a quadratic, okay, we can simultaneously solve two linear equations and there will be one intersects. Okay, there will be one intersects. Or if they're parallel, there will be no intersects. Okay, if they are the same line, there will be infinite many intersects. But for a quadratic and a linear, there will have three situations. What are those three situations? The first one is they not touch at all. There will not have intersection. Okay, no point in common. So when we're trying to solve for that quadratic and that linear, we'll have no value can be solved out. There's no solution case. Okay, I can't solve out any solution. We have that one. It's just a touch case. Okay, something and something, they just touch each other. They're not intersects. Okay, they touch each other. So that's a tangent. That's called the line of the tangent. Okay, that's called a tangent line. I will have exactly 1 point of intersection. When we're trying to solve that simultaneously, I can solve out one answer. Okay, I can solve out one answer only. So that's a tangent. And then we also have a second. Okay, second is this one. Tangent is that one. Second is the line intersects the curve twice. Okay, they just cut it, go through the quadratic. Go through the quadratic. That's called a second. For a second, you will have 2 points of intersection. You will intersect that graph twice. When you're trying to solve the equation, you will solve out two values. Okay, you solve out two values. So, again, now you know that for solving a linear and a quadratic simultaneously, I can have the case there will be no solution at all, there will be one solution, or there will be two solutions. Okay, three cases. Okay, so three types. Okay, three types. There's three types of the graph. So now let's have a look. How do we solve them simultaneously? I can't have three for sure. Okay, I can't have three for sure. So let's have a look at the first one. I want to solve those two simultaneously. Okay, y equals to that and y equals to that. So simultaneously solve. Y is the same y value. So x squared minus 3x equals to 4. I want to solve for quadratic. I must have everything on one side. Okay, ax squared plus bx plus c. I must have everything on the left. And that's very easy to factorize. That's x minus 4 and x plus 1. So I will have x equals to 4 or x equals to -1. X equals to 4 or x equals to -1. But I want to find the points of intersection, not the x value of the intersection. We need to care about the y value as well. But the y value is very obvious. That's just 4. So it's 4, 4, and -1, 4. But what I was looking for is before we factorize it, tell me what do you think the discriminant will be? Greater than 0, less than 0, or equals to 0? Just decide without calculating. Greater. We have two solutions already, which means our discriminant must be greater than 0. Well, if I want to have two solutions later, I must in that step have discriminant greater than 0. Otherwise, I can't solve out two solutions. So what's the discriminant? 9 minus 4 times 1 times negative 4. That equals to 25, which is greater than 0. Okay, remember in that case, if I will have two solutions later, I must have discriminant equals to greater than 0 here. Okay, let's have a look at exercise B. Exercise B, we have this graph here. Okay, we have this graph here. 2, 2. Okay, so let's solve for that. We solve them simultaneously. I will have minus 4x squared minus x plus 6 equals to 3x plus 7. Same y, same x. So y equals to y. Then the other two sides must be the same. If I move everything to the right, 4x squared plus 4x and then plus 1 equals to 0. Let's check the discriminant here. 16 minus 4 times 4 times 1. That equals to 0. Okay, give me a prediction. How many answers you will solve out? 1. Okay, discriminant equals to 0. You will have one solution. You will have one solution in the end. Okay, if it's greater than 0, I will have 2. If it's less than 0, there will be no solution at all. Okay, so we are aiming for one solution. And if you can see, that's a 2x plus 1 squared equals to 0. If you factorize that, that's a 2x plus 1 squared. It is a perfect square. 2x squared is 4x squared times 2ab, which is 4x, plus b squared, which is 1. So your x will be only have one solution, that is negative half. That's negative half. So 2x plus 1 equals to 0 gives you x equals to negative half. Okay, x equals to negative half. So if x is negative half, what is the y value? How can we find the y value? Well, obviously we need to substitute. But which one you will substitute in? We have the first one and the second one. Which one you substitute? Will you substitute in the quadratic or you will substitute in the linear? Linear. Well, they will get the same answer, but linear will be easy to calculate. The y is the same y. You can substitute in any function. You will give the same y value for negative half. But obviously linear is easy to calculate. So I will solve y here. Negative half times 3 plus 7. 7 is 14 on 2. That's 11 on 2. So the coordinates of the tangent point, okay, that's the parabola and that's the point. Just touch it, okay, just touch it. So that touching point is negative half and 11 over 2. Okay, negative half and 11 over 2. Okay, next one. Next one, we have y equals to x squared plus 3x minus 1 and y equals to x minus 2. So I will find the equation first. We'll set up the same y together. And we'll solve for that. X squared plus 2x plus 1 equals to 0. Okay, what's the discriminant here will be? B squared minus 4 times A times C. That is discriminant equals to 0 as well. If discriminant equals to 0, I will have one solution. Okay, I can predict I will have one solution. Or if you already know that there is one solution, I can predict that discriminant must be 0. They are the same. Okay, the number of solutions and the large or small of the discriminant, they are the same thing. Okay, they are the same thing. So that's the x plus 1 squared. If you can see that, that's a perfect squared. X will be minus 1. So again, I will substitute that into the linear because it's easy to calculate. You have y equals to minus 3. So the point of intersection is minus 1 and minus 3. Alright, for D. Okay, for D, it's not a very nice equation compared to before. Okay, before we all have y equals to something, and I can directly equalize both equations. But in this one, it's y equals to something and 2x minus 3y equals to minus 4. So I can't directly equalize both sides. Instead, what we can do is substitution. Because one function is in terms of x, y to be the subject. So I can substitute. So 2x minus 3x squared plus 2x equals to minus 4. That's substitution. But that must be in the bracket. That must be in the bracket. So 2x minus 3x squared minus 6x equals to minus 4. Put everything to the right. 3x squared plus 4x minus 4 equals to 0. Let's have a look at the discriminant. The discriminant is 16 minus 4 times 3 times minus 4. That is 16 plus 12 times 4, which is 48. That is 64. Discriminant greater than 0 here. How many solutions you expected? 2. Okay, you will expect 2 solutions here. Have a think about that factorize. 1, 3, 2, 2 will definitely be the case. You need a positive 4, so you put the negative 2 here. That's a 6 minus 2 equals to 4. Okay, 1, 3, 2, then negative 2, so it's x plus 2 and 3x minus 2. So x equals to minus 2 or x equals to 2 on 3. Yep.
That's why I think it's
Which one is x equals to 2? This one? Well, it's 3x minus 2 equals to 0, right? So it's 3x equals to 2, right? And x is 2 on 3. Okay, now I need to work for y values, but I can't just do them together. I need to do them separately. So for this answer, I will have they are in pairs. Okay, they are in pairs. So for -2, that y will be -2 squared plus 2 times -2. That is just a 0. So that is a -2, 0. That is a -2, 0. And for that one, y will be 2 on 3 squared plus 2 times 2 on 3. That is a 4 on 9 plus 4 on 3, which is 12 on 9. Y is 16 on 9. That's a 2 on 3, 16 on 9. Okay. Alright, so by looking at those 4 exercises, we can see if you see the after we combine the 2 equations, set up the simultaneous equation together, we equalize both sides, or we substitute y into another function, we make whole equation just having x, and that's a quadratic. And if we can find the quadratic, the discriminant of that quadratic, we can predict the number of intersections later. Okay, we can predict the number of intersections later. Yeah, this is a very important concept, okay, because year 12 students, they still have this kind of question on their VCA exam, okay, final year exam. That's a very important concept. Let's have a look at example 2. Okay, let's have a look at example 2. Example 2 says, determine for which value of k the line 2x plus k does intersect with the parabola x squared plus 3. Okay, so now is you have a value unknown. You don't know the k value. Okay, you don't know the k value. But what you know is I want those 2 line intersects. Okay, I want those 2 line intersects. So what I can do, for some k value, it can't intersect. For some k value, it can intersect. What I can do is, well, I'll show you a diagram first. Okay, I'll show you a diagram first. Okay, 0, 3. And let's label some other points. 1. Okay, the graph of this quadratic will look like this. Why is not symmetrical? Okay, that's the shape of this graph. And then we have a linear. We don't know the k value, which means we don't know the intersects. But what we know is the gradient. The gradient is 2x. Okay, the gradient is 2x. Let's just sketch y equals to 2x. Okay, y equals to 2x. I will use a red line to sketch that. That's 1. That's 1, 2. Well, it's okay. I'll just sketch y equals to 2x. Can you see if k is 0, I never intersect with this graph. I will never intersect with this graph. But I can like also move that down. Okay, parallel move that down. Say k is -1, I still not intersect. I can't move in anything down, but I can move the graph up if k is positive. So if I move that up, if it just be here, okay, this is the point where they start to contact each other, where the line starts to contact each other with the point, with the graph. That has one point of intersection here, which is the tangent, But if I have a larger value of the k, I can keep this k even larger. I will still contact with that graph and intersect at two places. What are we doing at the back? Okay, we will still intersect with the 2 points. Okay, we'll still intersect with 2 points. So I can have larger k value. I need to find what this line, the k value is. And any k value greater than that, I can make sure I will keep contacting with the graph. So I will set up the equation. I'll just show you a diagram way. It's not necessary to sketch the graph at all. So let's have a think. We want to solve for y equals to 2x plus k and y equals to x squared plus 3. Want to solve for that simultaneously. So 2x plus k equals to x squared plus 3. Moving everything to one side because that's a quadratic graph. I will have x squared minus 2x plus 3 minus k. I'll put a bracket around 3 minus k because that's all constant. Depends on what is the k value. Say k is 1, that is 2, k is 3, that is 0. So it really depends on the k value. Alright. Then I will think about discriminant. What I want here is I want 1 or 2 solutions from this equation because I want them intersects. It must have 1 or 2 intersections. Okay, or I must have like values. I want to achieve that. So how I can achieve that is discriminant greater or equals to 0. I want 1, which is discriminant equals to 0. I want 2, which is discriminant greater than 0. Overall, I need discriminant greater or equals to 0. Okay, greater or equals to 0. So what's discriminant? A equals to 1, B equals to -2, C equals to 3 minus k. Write A, B, C values. Okay, A, B, C values. So I want discriminant is B squared minus 4 times A times C. And I want that greater or equals to 0. That's a 4 minus 12 plus 4k greater equals to 0. 4k needs to be greater or equals to 8. K is greater or equals to 2. Okay, K is greater or equals to 2. Okay, and therefore I can solve out what I have. Okay, I need the K greater or equals to 2. The possible value for K is K greater or equals to 2. Okay, so it's totally decided by the discriminant. So you just need to know what I want. I want 1 or more solutions. To achieve one solution, I must have discriminant equals to 0. To achieve 2 solutions, I must have that greater than 0. So overall, I need the discriminant greater or equals to 0. I can make sure there is at least 1 solution. And I solve for whatever I have for the k values. Okay, example 3. Let's have a look at example 3. The line y equals to mx is the tangent to the parabola y equals to x squared minus 2x plus 4. Okay, first of all, I want you to sketch this graph. Okay, decide by yourself how to sketch it. Use your own way to sketch it. Y equals to x squared minus 2x plus 4. If you have finished, you can have a look at my answer. That's the shape of this graph. The only way you can use is the completing square. Okay, I can't factorize because there's no x-intercept. I can't use the quadratic formula because there's no x-intercept. So the only way left will be completing square. Okay, completing square. So after you complete square, you will have x minus 1 squared plus 3. Okay, you have that, and you have this graph. And now you know there's a linear. Which is y equals to mx. Okay, it's here. Y equals to mx. What's the important thing for this point? Anything special about this line? Which point will definitely pass through? Which point, like, will be always on this line? Y equals to mx. Anything special for this point, for this graph? That's a linear graph. And it's always passed through which point? 0, 0. Okay, it's always passed through 0, 0. So that's a line. Basically, rotate here. Okay, if you can see here, well, that's just a line. Okay, keep rotating here. Because M is the gradient, right? That's just a line, just keep rotating like that. Okay, so you can rotate 360 degrees, but passing through here. So it can be any line passing through this point. So can you sketch a line which is a tangent to this quadratic for me? Any line that can be a tangent to this parabola. Just roughly, not necessarily to be like a really exact point. Okay, that's one I can find. Do you have any other points you think will be possible? On this side. Okay, on this side. Can be on this side and this side. So I'll use another color to do that. I'll use a pink. Well, it's not really accurate, but like it can be this pink point as well. Alright, that's the guess I have. Okay, I can have two linear lines that can be the tangent to this graph. So that's all my guessing. What I want is I will set up the equation for this graph. I can solve them simultaneously. So what I will do here is that's x squared minus 2x minus mx plus 4 equals to 0. And that is x squared plus minus 2 minus mx plus 4 equals to 0. So I want to see what's the coefficient of b. Now this m is not combined with the constant because this involves the x term. So it will be combined together with the x term. Okay, so what it has constant will be go for the c value. If got the x term, it will go for the b value. So here we have a equals to 1, b equals to minus 2 minus m, c equals to 4. I can say also b is a minus m plus 2 as well. I can do that. Well, I want the tangent. Tangent means for each tangent there will only be one solution, right? If there's a tangent, there will be only one solution to the graph and the quadratic. So that will give me my discriminant must be 0. Okay. If my discriminant must be 0, I will have minus m plus 2 squared minus 4 times 1 times 4 equals to 0. Okay, minus 1 squared will get 1, so it's m plus 2 squared minus 16 equals to 0. So that's m plus 2 squared, or not 12 squared equals to 16. What m plus 2 equals to? Or negative 4. Okay, plus minus 4. You square root both sides, plus minus 4. So m plus 2 will be plus minus 4 minus 2. Okay, you can't leave your answer like that. You need to explain the answer. So minus 4 minus 2 is minus 6. Or you have plus 2 minus 2, which is a positive 2. So one of the gradient can be minus 6 and the other gradient must be 2. So this line, red line, is y equals to 2x. This pink line will be y equals to minus 6x. Okay. 2x and 6x. Okay. Alright, next one. What I will have next is, can you explain why there are two possible values of that? Diagram may help. Okay, I already sketched a diagram for you, so that can on the left hand side and right hand side both have a tangent. So that's why there will be two m values we can solve out. The diagram can show that. Okay, next one. Next one is very interesting because what we want is how the m value can change so that it can intersect twice with this. Okay, twice with this. Let's have a think. Well, if I have a line in this direction, can that intersect? This blue one, can that intersect? No. If it's here, it still can't intersect. So until the red line it starts to intersect, therefore, I can have a larger gradient compared to that point. Let's think about this. Okay, this blue line, well, I can't use blue, so hard to see. Let's use a black. Can you see this black line? That line intersects with the graph twice. So any line in between that two lines will all intersect twice. Can you think about that? If you have a line outside, it's not going to intersect. Okay, the gradient must be in between, no, not the gradient, the line must be in between those two pink and red lines. And then I can intersect the graph twice. So let's think about the positive side first. Do you think the black one get a larger or smaller gradient compared to 2? Larger. Okay, get a larger one. So I keep rotate that way. I will keep getting larger and larger gradient compared to 2. And I can keep intersect with the graph twice. Until here, that's an exactly vertical line. It's an exactly vertical line. I can't really have a vertical line. That's not a linear at all. That will be x equals to something. So it can be really, really large gradient, almost to perpendicular. So my m value can be anything greater than 2. Can be anything greater than 2. I can keep having larger gradients. Again, it will always intersect here, but not finished. How about the negative side? Okay, this is -6. I can also have a negative point passing through here. Let's just use the color. I'll use that color. Well, my graph is not really sketched well, but have a think. If you rotate that a little bit inside, this graph will intersect on that side with it as well. Okay, so my graph is not really to scale, but it can intersect future somewhere above here or some at that side because it's a linear and a projective. It can intersect. It's passed through once here. It's not a tangent, so it will definitely intersect somewhere else. Okay, definitely intersect somewhere else. But on my graph, it's too high. Can't see it. But this will, just compared to this pink one and this dark red one, how about that gradient? Do you think, like, if that's -6, can you give me an example for that one? Any possible one? -8, okay, an even negative number, because it's getting even steeper compared to that point, even steeper. So that can be a value become even steeper on the negative side compared to -6. Therefore, my m can also be smaller than -6. Okay, it can be a larger, like they need to get more steeper. Okay, the thing is, compared to those two lines, it should get more steeper. On the positive side, it will be greater than 2. On the negative side, it will be even less than -6. And then those lines can intersect twice with the quadratic. Okay, so can intersect twice with the quadratic. So you have those two values. you can have any m greater than 2 or any m less than -6. You will intersect this function twice. Okay, you will intersect this function twice. Well, this is a really something extended, like it's a really extended question. So if you can't get past C, that's fine, but you must get A and B. Okay, you must get A and B. And the question above is the standard one. Okay, the question above is the standard one. You can do that as well. So you just need to care about discriminant. I want two solutions. Discriminant must be greater than 0. But why I'm not talking about the discriminant for that question? So because let's have a think about the discriminant here. The discriminant is that one, m plus 2 squared minus 16. That's the discriminant. I need that. Okay, I need that point to be greater than 0. Okay, I need discriminant greater than 0. Okay, I need discriminant greater than 0. But this is a quadratic inequality. We haven't learned how to solve quadratic inequality yet. So that's why I'm not really looking at that. If you have calculator, you can solve that by using calculator. Okay, by using calculator to solve. But like, we can't really know how to solve it by hand in year 10. We'll learn that next year, at the beginning of next year. But what you just need to think about, yes, discriminant method can still apply, but we don't know how to solve for it. That's why I'm going through the graph for you and ask you to have a look how the gradient can change to satisfy the condition. Okay, so I'll stop here today. Tomorrow we'll finish the last exercise.